Welcome to multiple choice question 22 of the 2010 Mathematical Methods Exam 2. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. And now before we move on, I'd just like to point out that the use of the CAS calculator could be used to assist with answering this question. So for question 22, let f be a differentiable function defined for x greater than 2, such that the following integral statement, where a and b are both greater than 1, is true, and where asked, the rule of f of x is one of the following. So to help attempt this problem, what we're going to do is we're going to separate it into the left-hand side and the right-hand side. So the left-hand side, if I do that in blue, this is going to equal the antiderivative of f, I'm going to represent symbolically as capital F of x, evaluated between the lower terminal of 3 and the upper terminal of a times b plus 2. So using our fundamental theorem of integral calculus, we just take the antiderivative capital F and evaluate it at the upper terminal of a times b plus 2, and then we subtract away from that the antiderivative evaluated at the lower terminal of 3. So that's one way we can represent the left-hand side. Then the right-hand side, if I do that in green, this is going to equal two separate integrals, so I'll keep their antiderivatives separate. So both are going to still have the antiderivative capital F, and the first one goes from 3 to a plus 2, so we put 3 and a plus 2 as those terminals, and then we add on to that the same antiderivative f of x, evaluated between this time 3 and b plus 2. So to evaluate that and make it a little bit more similar to what we found in the blue, or the left-hand side, we're going to have the first antiderivative evaluated at its upper terminal of a plus 2, and then we subtract away the antiderivative evaluated at the lower terminal of 3, and then we add on to that the second antiderivative evaluated at the upper terminal of b plus 2, subtract away the antiderivative evaluated at its lower terminal of 3. So we now know that this line here is going to equal this line here, so that's what I'm going to summarize in the next line. So therefore, the left-hand side, which was capital F of AB plus 2 minus capital F of 3, is equal to the right-hand side, which was F of A plus 2, and then plus f of b plus 2, and then collecting like terms, this f of 3 and f of 3 here gives negative 2 times f of 3. And finally, we could simplify by adding f of 3 to both sides. And now this is something that we can use our calculator to help to work out. On the CAS calculator, go into the main menu. Next, we want to bring up the soft keyboard by pressing the keyboard button on the keypad. And then under Math 2, we want to find the integral. So to do this question on the CAS calculator, we're actually going to essentially do trial and error from this point onwards. So starting with option A, we want to find the integral of the square root of x subtract 2. And we're going to do that with respect to x, and hitting execute gives this expression. Next, what we're going to do is we're going to drag that down and define it. And then we highlight it and go interactive define. And the function name, I actually want to use capital F. So I'm going to go to ABC and change this to capital F, and then hit OK. And then we're going to use, under keyboard, we're going to find in the catalog the judge button. So J and judge, and we're going to input that. And what we want to do here is we want to input the same equation that we underlined in orange before. So that is this equation here. So hopefully I've put it in correctly. And now if I hit execute, this says undefined. And what I really want this to say is true. So we'd have to go through and we'd have to change our function to see which one gives the true output that would mean it's the correct option for this question. So I know that it's option E. I've been through this question before. So I'm going to delete this out and just show that that's the case. So back here, we're going to put the fraction in 1 over x subtract 2, and then we're going to hit execute, and then we're going to drag down this antiderivative into here, and when I hit define and just hit execute, it will rejudge this expression and tell us that it's true. So you would have to go through in the exam, I suppose, all of those options until one came up as true, and they'd keep on coming up as undefined or false. And when you find the one that says true here, you know that that's the one that is the correct option for this question. So from the CAS calculator, we found that when f of x, which is what we're asked to find, when f of x was 1 divided by x subtract 2, it had an antiderivative that satisfied this equation that we developed down the bottom of the slide. So that means that E is the correct answer for this question. So from the examiner's report, we can see that 29% of students got this question correct, with a fairly even spread of options selected by students. So that might indicate that a lot of students just guessed an option to this question. The examiner's report goes on to give a very brief conclusion as to where the answer might have come from. However, it might be more useful for us to look at the actual log law that they're referring to here that allows us to show that this is in fact equal, as well as what the calculator quoted as being true on the previous slide. Before we get into that, it just says in the report that a suitable choice of values could have been used to test the relationship. So you could have picked some suitable values for A and B, plugged them in, and just trial and errored the question as well as a different approach to the one that we saw in this video. So this is where we arrived at on the previous slide. And what we're going to do now is just see that this does hold true if we use the function f of x is 1 divided by x subtract 2. So just quickly over here, if we were to integrate 1 over x subtract 2 with respect to x, we'd find that the antiderivative of that is log e of x subtract 2. So therefore, our capital F of x function is equal to log e of x subtract 2. So we're now going to use that in the statement that we found back here. So plugging in that equation for f of x, we'd find that the left-hand side is going to equal log e, and wherever there's an x, we're going to replace it with ab plus 2. So we're going to have ab plus 2, but we still have a negative 2 here, so we have to remember that. And that's going to equal log e, and this time we're going to put in a plus 2 for x, and we'll still have a minus 2 there. And then we add on to that log e of b plus 2, and we still have the minus 2. And then finally we subtract away from that log e of 3 subtract 2. So that's when we substitute all of those things into the capital F of x equation we just found. So simplifying that a little bit, we have that this would be log e of simply ab, as plus 2 and minus 2 would cancel. And this is going to follow a pattern along the right hand side as well. So the plus 2 and minus 2 would cancel here, and we just have log e of a left behind. And then we'd have plus simply log e of b. And then here, this is simply log e of 3 subtract 2 is log e of 1. And we know that log e of 1 is simply 0. So that is just subtract 0 off the end, so we can forget about that. And now what's left here, log e of a times b equals log e of a plus log e of b, is the log law that's well established. So that's just showing that this is actually true and that the option E is the correct one for this question.